Einstein, towards the end of his life, said he committed a sin when he created general relativity because he didn't show how rods and clocks emerge from the equations of the theory. They've just brought in from outside. And from the way he wrote, I think in the terminology of the Catholic Church, he regarded that as a venial sin, not too serious. But I'm going to suggest it might have been a mortal sin, because a general relativity now we know is incredibly good at the present epoch of the universe with the gravitational waves, the prediction of what they'd look like, and they've been found. It's absolutely fantastic. But what about the Big Bang? In fact, I think it's fair to say no relativist today would stick their neck out and say they know exactly what the Big Bang looks like. Now, next slide, please. What is very striking is that there is a perfectly known, mathematically absolutely rigorous theory of Big Bangs in Newtonian theory. And it started in 1907 with Carl Sundman, who showed that three gravitating particles could collide in a point. And if you time reverse such solutions, they're Big Bangs. This is 20 years before Hubble. Next slide, please. Now, sorry, I should have said that he said that the shape of the three particles form must be either become a triangle or collinear. Now, it's all determined by the ratio of two lengths. Now, the first length, so there's the distances between the particles are Rij, and the root means square length. Oh, the equation is not quite right. It's the sum of the squares of all the distances that take the square root if it's equal mass particles. And then there's the mean harmonic length, which is minus the inverse of the Newton gravitational potential. So you multiply those two together and you get something I call the shape complexity. And it's also what the N-body specialists call either the shape potential or the normalized Newton potential. And you may not be aware of it, but that one dimensionless number actually determines everything in what is happening in Newtonian gravity if you get rid of every last trace of the absolute elements that Newton introduced: absolute time, absolute orientation, and above all, absolute scale. And so the complexities, the shape complexity is a dimensionless pure number. And all Newtonian Big Bangs begin at critical points of that shape potential. They're either minima or saddles. Next slide, please. Now, that number is positive definite, has an absolute minimum, which corresponds to the most uniform, but not absolutely uniform shape that the particles can form. And this is what they look like. The angular momentum must be exactly zero, and there's a strong case for the energy being zero. And that's what, for 5,000 particles, it looks like the very first instant of time. And there's a section through it on the right. It's incredibly uniform, and that's due to Newton's potential theorem, which holds uniquely for the 1/r potential and in 3 dimensions. It's a very extraordinary fact. And the first thing to note, this comes out of Newton's equations, the thing that Einstein said should have happened in his general relativity. All the smallest separations are nearly equal, and they're measuring rods, so they're there. And they tell you actually at the Big Bang, if you were inside that, what you would see around you would be a nearly uniform distribution of the particles. You wouldn't find them all sitting on top of each other because you're in it. So next slide, please. This is what the early stages of a 4-particle Big Bang looks like. So there's 4 particles. It starts as a regular tetrahedron, and then the velocities are chaotic at the start, but very soon 2 particles form as a Kepler pair going around their common center of mass, and in that they become a rod, clock, and compass all in one. And at the same time, the other 2 particles fly off in rectilinear, what becomes ever better rectilinear motion at a uniform speed. And this is order created out of disorder. It is the absolute opposite of the entropic order. And this is all to do with the fact that the Newtonian configuration space is unbounded, but when you look at shapes, you've got a compact thing and it changes things completely. Next slide, please. Now, the other thing which is really marvelous, this is in 2 dimensions, where the absolute minimum looks like that disc there. Then a discovery made about 3 years ago at the observatory in Paris by a Spanish student just looked at when the complexity was a little bit above, only 1 or 2% above the back, and discovered this incredible structure. It's just
you mean that building with the yellow windows?
His supervisor sent me an email. He's discovering lines.
Yeah, but that's not where I got the key.
And it's unbelievable structure. So this is, I think, we may have stumbled on the principle of creation. The etymology of creation comes from "ker," which means to grow. Did Sundman stumble on the principle of creation? Next slide, please. This is typical shapes that you would have in a 2-dimensional 100 particle universe. Top left is the Big Bang, and then you get this structure. Look how the structure grows. Look at that growth. Look in this one. There's one with a beautiful, here, with a nearly perfect circle and 2 arcs there. It's just amazing. This comes, so that complexity, you say, what number, which is scale invariant, you have particles in space, characterizes the extent to which they're uniformly distributed or clustered. The simplest, obvious, bloody obvious answer is our shape complexity, and it generates all these things. I think that could be claimed to be the principle of creation. Next slide, please. I'll jump that one. All I want to say is actually the universe is not expanding, it's changing its shape. Next slide, please. Now, I've been an independent for 55 years, living in this fabulous farmhouse from 1659, which I bought at auction from College Farm in Oxford, New College in Oxford, the day before President Kennedy was assassinated. And people like Tim Palmer here have been here and we've had discussed things. It's the ideal location for things. I'm getting near the end of my life. I'd love it to continue as a workshop so that my children can visit it for a few weeks in the year. And otherwise, it's perfect for 3 or 4 people. And there's a thatched barn where you could have perfect workshops for 10. It could be very like Oberwolfach for mathematicians in the Black Forest in Germany. So are any of you here hugely rich and would help with that? or do you know somebody who might? Anyway, thank you very much.